Imagine the ultimate act of cosmic defiance. We gather every single nuclear weapon ever conceived, every warhead from every arsenal on Earth, and we point them not at each other, but at something far grander, far more distant. Jupiter. The idea is simple, yet audacious. Could we, with our collective destructive power, ignite the gas giant, turning it into a brilliant second sun in our solar system? It sounds like science fiction, a desperate gamble for humanity, but what if we actually tried? The notion of creating a second sun is captivating. After all, Jupiter is enormous, primarily hydrogen and helium, just like our sun. It's often referred to as a failed star. So, a few thousand super-powerful explosions, surely that would be enough to kickstart nuclear fusion, right? The reality, however, is far more complex, and frankly, far less dramatic in the way you might imagine for Jupiter, but terrifyingly dramatic for us. To understand why this wouldn't work, we need to grasp the sheer, incomprehensible scale of Jupiter. It's the largest planet in our solar system, so massive that it contains more than twice the mass of all the other planets combined. You could fit over 1,300 Earths inside Jupiter. Its volume is staggering, its atmosphere extends for thousands of kilometers, and its core, while still largely theoretical, is thought to be incredibly dense and hot, under immense pressure. Almost asterisk, has enough mass to become a star, but almost is a colossal understatement. To truly ignite and sustain fusion, Jupiter would need to be roughly 70 to 80 times more massive than it currently is. It's simply nowhere near that threshold. Now, let's talk about our arsenal. Estimates suggest there are around 13,000 nuclear weapons in the world today, with varying yields. If we were to somehow detonate all of them simultaneously, the combined yield would be equivalent to tens of thousands of megatons. On Earth, this would unleash an unimaginable cataclysm. Tsunamis, firestorms, a nuclear winter plunging the planet into a darkness that would end civilization as we know it. But Jupiter is not Earth. Imagine dropping a single grain of sand into the Pacific Ocean. That grain of sand is roughly analogous to all 13,000 nukes hitting Jupiter. The explosions, individually and collectively, would be immense by human standards. They would create colossal fireballs, shockwaves rippling through Jupiter's upper atmosphere, perhaps even carving temporary, localized holes. We might see spectacular flashes of light, a temporary disturbance in its cloud bands visible from Earth. But these would be mere cosmetic blemishes on a body so vast. The energy released would be absorbed by Jupiter's incomprehensibly deep and dense atmosphere, dissipating without reaching its core, without initiating any kind of sustained nuclear fusion. Jupiter would absorb our most powerful weapons and barely shrug. While our efforts would be a galactic-level fizzle for Jupiter, the fallout for Earth would be catastrophic. The initial explosions on Jupiter, even if they don't ignite it, would generate an immense pulse of radiation. X-rays, gamma rays, and highly energetic particles. This pulse would travel across the vast distance of space, reaching Earth in minutes to hours. Our planet's magnetic field offers some protection, but this torrent of radiation would overwhelm it, frying every unprotected satellite in orbit. Communication networks, GPS systems, weather forecasting, even the very internet that connects us, all would go dark, plunging modern society into chaos. And that's just the immediate aftermath. Over the longer term, the gravitational disruption, however subtle, becomes a chilling prospect. Jupiter acts as a gravitational shepherd in our solar system, especially for the asteroid belt and the comets in the outer reaches. Even a slight temporary perturbation from our nuclear bombardment, though insignificant to Jupiter itself, could nudge countless asteroids and comets out of their stable orbits. Over years, decades, or even centuries, these once stable celestial bodies could be redirected, some of them potentially set on a collision course with Earth. We would have essentially shot ourselves in the foot, creating an existential threat from space where none previously existed. So, no, firing every nuclear weapon at Jupiter would not create a second sun. It wouldn't even slightly alter